let's remember our special right triangles. Remember we talked about a pi over 4 right triangle. And the general relationship on this triangle, if I have a pi over 4 right triangle, the general relationship will be 1, 1, square root 2. I can talk about the pi over 6, pi over 3 right triangle. The special relationship here, remember, is the 1, 2, 3, where the square root 3 is always opposite the pi over 3. Okay? And similar, the pi over 3, pi over 6 right triangle is just the exact same triangle, except I just have to remember that the square root of 3 goes opposite the pi over 3, the hypotenuse is always 2, and the 1 is always opposite the pi 6. Now, if you haven't seen this yet, make sure you go back and view the lecture on the 45, 45, 90 and the 30, 60, 90 right triangle. All right. Let's recall from the previous lecture. Two triangles A and B, if two triangles A and B are similar, then there exists a constant K such that the corresponding lengths of the sides of the triangle differ by a multiple of K. For example, we did something like this. It might not be exactly the one we did, but I think from the previous lecture we did something like, let's just say this was 10. This isn't exactly the same problem we did, but it's close. Now, I know this isn't to scale, but I just want to show you something here real quick. Let's say that these two are similar triangles. Okay? That means the angles are all the same. Well, if this length is 5 and this one is 10, it says that there exists this constant K such that each corresponding side is a multiple of K. Okay? So I know that 5 times some K must equal 10, or K is 2. So since 5 times 2 is 10, 12 times 2 is 24, so that must have length 24, and 13 times 2 is 26. So there's a little refresher from the previous lecture. Okay. Now, let's take a look at this problem. Find the lengths of the missing sides. Now we're given that this is a pi over 4 angle, so this is pi over 4. Now, remember, we do know that special relationship is 1, 1, square root of 2. Okay? This is the one we have to memorize. Now, how are we going to find the missing sides of this triangle? Well, we simply have to find out what that constant K is. Well, I'm given this side as 1. Okay? So I know that square root of 2 times some K must equal 1, and we'll solve for K. So K is equal to 1 over the square root of 2. So if I take the square root of 2 times K, I get 1. If I want this side, I'll take 1 times 1 over square root of 2, which is 1 over square root of 2, and 1 times 1 over square root of 2, and I've got my missing sides. Okay? So it's very important that you have this general relationship memorized. Then it's fairly easy to find your K. Let's do another one. This angle is pi over thirds, and I'll darken it so you can see it. So if that angle is pi thirds, that means this one is pi sixths. Okay? And I'm given that the hypotenuse is 5, and I want to find the remaining two sides. Well, let's go ahead and give ourselves a reference triangle. If this is pi over thirds, and this is pi sixths, remember the special relationship is a 1, 2, square root 3, where the square root 3 is always opposite the pi thirds. Now let's try to find K, and then we can figure out the remaining two sides. Well, I'm given the hypotenuse is 5, and I know the hypotenuse over here is 2. Therefore, 2 times some K is equal to 5. And I'll divide both sides by 2. So there is my k. Now I can easily find the remaining two sides. If this side is 1, this side is going to be 1 times k, or 5/2. If this side is square root of 3, this side is going to be the square root of 3 times k, which is 5/2 times the square root of 3. Now, if we were to do the Pythagorean theorem, you could easily show that a squared plus b squared equals c squared. And you might want to check that out just to make sure. Let's do one more. It's very important that you can do this. Okay, I'm given a hypotenuse of 1, and this is a pi/6 angle there. Therefore, this is pi/3 here. Now let's go ahead and draw a little reference triangle and label it. I'll make it look just like this one. That's our special right triangle. Again, it's a 1, 2, square root 3. Square root of 3 is opposite the pi/3. 1 is there, and 2 is the longest side. All right, let's try to find k. Again, I'm given this is 1, and this is 2 here. So 2 times some k gives us 1. So k is equal to 1/2. Okay. Now all I have to do is take the corresponding sides and multiply it by k to fill in the blanks over here. 2 times 1/2 is 1. Square root of 3 times 1/2 is the square root of 3 over 2. And 1 times 1/2 is 1/2. And I've completed it. So again, you can see the importance of knowing our special right triangles that will help you complete these missing sides.